Hello everyone. In this video, we shall cover the sum and difference identities. When we say sum and difference identities, we focus on the trigonometric functions wherein the parameter is expressed as a sum or difference of two angles. So for example, if we have the sine of the quantity of a plus b where A and B are angles, then we can find an expression that is equivalent to this using a sum identity. Now, for cosine of the angle A minus B, then we can find an equivalent expression using a difference identity. Now, in this video, we will not derive the formulas for the sum and the difference identities, but instead we will just verify an example for one of those identities. So what are these sum and difference identities? So first we have the sine of the sum of two angles A and B, and then we have the sine of the difference of two angles A and B. So for the first one, sine of A plus B is equivalent to the product sine A times cosine of B plus cosine of A times sine B. So since we're using a sum in the parameter, then the equivalent expression will be the sum of the products of sine and cosine. And then for sine A minus B, since we're using the difference here in the parameter, then the equivalent expression is also a difference of sine A times cosine B and cosine A times sine B. Now for the cosine of the sum and the difference, then it's equivalent to cosine of A times cosine of B minus sine of A times sine of B. But if you observe here, since the parameter here is a plus sign, or it is a sum, the equivalent expression must be a minus sign. So that is the sum identity for cosine. And for the difference identity for cosine, we shall use positive to separate the products cosine A times cosine B and sine A times sine B. Now for the sum and difference identity for the tangent, then we have tangent of A plus B is equal to tangent of A plus tangent of B. So observe here that if we are using the sum identity for tangent, the numerator, the terms in the numerator are separated by a positive sign or a plus sign. But in the denominator, we have to reverse the sign in the numerator. So we have to follow 1 minus the product of tangent A and tangent B. So similarly, for the difference identity for the tangent, then we have tangent of A minus tangent of B. And then in the denominator, we will be reversing the sign for 1 plus tangent of A times tangent of B. Now, to verify one of these six identities, let us consider the first one, the sum identity for sine. So if we will recall, the value of sine 5 pi over 6 is equal to positive 1 half. So again, if you recall, the reference angle of 5 pi over 6 is pi over 6, and the value of sine using the angle pi over 6 is positive 1 half. But since 5 pi over 6 is in the second quadrant, then the value of sine 5 pi over 6 is also positive 1 half. Now, this 5 pi over 6 can be expressed as a sum of two angles. So we can actually write this as sine of 2 pi over 3 plus pi over 6. So you can actually verify if you combine these two angles, the combination will be 5 pi over 6. Now, since this is a sum of two angles, then we can treat 2 pi over 3 as angle A and pi over 6 as angle B. So using the sum identity for sine, we can verify that this is equal to sine of 2 pi over 3 times cosine of pi over 6 plus cosine of 2 pi over 3 times sine of pi over 6. Now, evaluating these trigonometric expressions, we get the following. Sine of 2 pi over 3 is equal to square root of 3 over 2. Cosine of pi over 6 is equal to positive square root of 3 over 2. And then we have plus. The cosine of 2 pi over 3 is equal to negative 1 half. And the sine of pi over 6 is equal to positive 1 half. So simplifying further, square root of 3 over 2 times square root of 3 over 2 is positive 3/4. And then we have plus the product of negative 1 half and positive 1 half, which is negative 1/4. So 3/4 plus negative 1/4 is equal to 2 over 4, which is equal to positive 1 half. So this verifies that sine of A plus B is equal to sine A times cosine of B plus cosine A times sine B. So that means using these angles, we have verified that this is indeed correct. Now, let's have another example. So here, let's use the sum and difference identity to determine the exact value of sine 5 pi over 12. So that means we are going to think of two angles such that the sum of the two angles is 5 pi over 12 and the difference of the two angles is 5 pi over 12. So in here, 5 pi over 12 can be expressed as 8 pi over 12 minus 3 pi over 12. So that's 8 pi minus 3 pi is 5 pi. And then since the denominators are the same, then we just copy the denominator when we combine this difference of two angles. So 8 pi over 12 can be simplified as 2 pi over 3, while 3 pi over 12 can be simplified as pi over 4. So rewriting this sine 5 pi over 12, sine 5 pi over 12 can now be written as sine of 2 pi over 3 minus pi over 4. So using the difference identity for sine, we can write this as sine of 2 pi over 3 times cosine of pi over 4, and then minus cosine of 2 pi over 3 times sine of pi over 4. So evaluating these trigonometric expressions, now we will get a sine of 2 pi over 3 is positive square root of 3 over 2. Cosine pi over 4 is positive square root of 2 over 2. And then minus cosine of 2 pi over 3 is negative 1 half, while sine of pi over 4 is positive square root of 2 over 2. So simplifying further, square root of 3 over 2 times square root of 2 over 2 will be square root of 6 over 4. And then minus negative 1 half times square root of 2 over 2 will be negative of square root of 2 over 4. So combining these two into a single fraction, we get square root of 6 plus square root of 2 all over positive 4. So this is the exact value of sine of 5 pi over 12. Now, for additional examples on applications of sum and difference identities, let's try this out. Fill in the missing information inside the parentheses. So for the first bullet, it says here sine 38 degrees times cosine of 52 degrees plus cosine of 38 degrees times sine of 52 degrees. So from the form of this left-hand side of this equation, this is a sum identity where A is 38 degrees and B is 52 degrees. And this is equivalent to sine of A plus B. So this gives us 38 plus 52 is equal to 90. So this thing is equal to sine of 90 degrees. Now for the second bullet, we have here cosine of blank times cosine of 25 degrees plus sine of blank times sine of 25 degrees, and it's equal to cosine of 135 degrees. So in this case, we can let the blank as A and 25 degrees as B. So since this is cosine times cosine plus sine times sine, this must be a cosine difference identity. So that means this 135 degrees must be equal to A minus B. But since B is 25 degrees, then we have A minus 25 degrees is equal to 135 degrees. And then transposing the negative 25 to the other side, that gives us A is equal to 135 degrees plus 25 degrees, which is 160 degrees. So this means that the missing information here is 160 degrees. Now for the third bullet, we have here tangent of 20 degrees plus tangent of 40 degrees over 1 minus tangent of 20 degrees times tangent of 40 degrees. So from the form of this expression, this must be the sum of some identity for tangent, where A is 20 degrees and B is 40 degrees. So in this case, this must be tangent of A plus B, which is 20 plus 40, which is 60 degrees. Now, for the next set of examples, we shall prove identities that will involve, the different sum and difference identities. So let's take a look at the following problem. Cosine of pi over 2 plus x is equal to negative of sine x. So in the left side, and this is our left hand side, and this is our right hand side. From the left hand side, we see that cosine has a sum parameters. Okay, so it's pi over 2 plus x. So if we will manipulate the left hand side, that's going to be cosine of pi over 2 plus x. So using the sum identity for cosine, we can write this as cosine of pi over 2 times cosine of x minus sine of pi over 2 times sine of x. And then evaluating cosine pi over 2 and sine pi over 2, this will give us, for cosine pi over 2, this is equal to 0 times cosine of x minus the value of sine pi over 2 is positive 1, and then it's multiplied to sine of x. Now 0 times cosine of x is 0, and then negative 1 times sine x would mean negative sine x, which is the right-hand side of our equation. So this proves this given identity. Now another example would be cosine of a plus b times cosine of b plus sine of a plus b times sine of b is equal to cosine of a. So using the sum identities for cosine and sine, we will have to expand the following. So our left-hand side will now be equivalent to, we have cosine of A times cosine of B minus sine of A times sine of B multiplied to cosine of B. Plus, the expansion of sine A plus B would be sine A cosine of B plus cosine of A times sine B, and then this whole thing will be multiplied by sine B. Okay, now, if we are going to distribute the cosine B to both of these terms and sine B to both of these terms, we will get the following. We have cosine of A times cosine square B minus sine A times sine B times cosine of B. And then distributing sine B to sine A cosine B, we get plus sine A times sine of B times cosine of B plus cosine of A times sine square B. And then we can actually uh, cancel out the sine A times sine B times cosine B with this positive sign A sine B times cosine B. And now we're left with cosine of A times cosine square B plus cosine of A times sine square B. And since these two terms has a common factor, which is equivalent to cosine A, we can factor cosine A, and then the second factor will be cosine square B plus sine square B. And this thing is equal to positive 1 by the Pythagorean identity. So cosine A times 1 is equal to cosine A, which is our right-hand side of the equation. So this proves the identity. And then another one would be prove the identity sine of u minus b over sine u times sine of v. So first, if we will manipulate the left-hand side, so sine of u minus b can be expanded as sine of u times cosine of v minus cosine of u times sine of v. And then that's the numerator of the fraction, so the denominator will be sine of u times sine of v. Now this single fraction can be written as the difference of two fractions. No? So if we divide each term in the numerator by sine u and sine u times sine v, then we have the following. No? Sine u cosine of v over sine u times sine v minus cosine of u times sine v over sine of u times sine of v. So in the first fraction, we can cancel out sine u and we get cosine of v over sine of v. And then minus for the second fraction, sine v will cancel out. So we get cosine of u over sine of u. Now using the ratio identity, cosine of v over sine v is equal to cotangent v, while cosine of u over sine u is equal to cotangent of u. And this is the right-hand side of our equation. So this proves the identity. Now for our final example, this time we have to look for the values of the trigonometric functions in which we are going to apply the sum and difference identity. So for this particular problem, we consider cosine of alpha is equal to 1/3 or positive 1/3, and tangent of alpha is said to be greater than 0. And tangent of beta is equal to 7, positive 7 over 24, and sine of beta is less than 0 or negative. So the instruction is we need to find the values of sine of alpha plus beta, the value of cosine of alpha minus beta, and the value of tangent of alpha minus beta. So let's expand first these three quantities. No? So sine of alpha plus beta is equal to sine of alpha times cosine of beta plus cosine of alpha times sine of beta. Now for cosine of alpha minus beta, this is equivalent to cosine of alpha times cosine of beta plus sine of alpha times sine of beta. And then for tangent of alpha minus beta, this will be equivalent to tangent of alpha minus tangent of beta over 1 plus tangent of alpha times tangent of beta. So to evaluate these three expressions, we will be using the values of these quantities. So right now, we have cosine of alpha. So we don't have any more problem for cosine of alpha because we have this value. And then we already have tangent of beta, which is 7 over 24. So we have this tangent of beta. So that means we're left to find the value or the values of sine alpha, tangent of alpha. And then we need to also find the value of sine beta and cosine of beta. So how are we going to find those values? So those values will come from this information. So just like what we did in the previous videos, we will be solving for the values of those trig functions by using this information. So let's proceed to another page that contains the same problem. So cosine alpha is equal to 1/3. So let's write it down here. Cosine of alpha is equal to 1/3. And then tangent of alpha is greater than 0. So first we need to find out the location of the terminal point of alpha. So since cosine alpha here is positive 1/3, then the terminal point of alpha must be in quadrants 1 or 4. And then tangent alpha greater than 0 means tangent is positive, and that means that P of alpha is in quadrants 1 or quadrant 3. So the common quadrant for these two information is that the terminal point of alpha is in quadrant number 1. So that means x, and the terminal point of alpha will have positive x coordinate and positive y coordinate. So since cosine is defined as x over r, now using the unit circle, using the circle with equation x squared plus y squared equals r squared, then this is equal to 1/3. So this means that x is equal to 1 and r is equal to 3. So we have to look for the value of y. So using the equation x squared plus y squared equals r squared, we have 1 squared is 1, and then r squared is 9. So here y squared is equal to 8. And then solving for y, we get y is equal to positive negative square root of 8 or positive negative 2 square root of 2. But since the terminal point of alpha is in the first quadrant, we have to take y to be positive square root of 2, a positive 2 times square root of 2. So now we can get the value of sine alpha. Sine alpha is y over r, so that's going to be 2 square root of 2 over 3. And then tangent of alpha is equal to y over x, which is equal to um, 2 square root of 2 over 1, which is simply 2 square root of 2. Now, for the information regarding data, we will use this time the uh, information for tangent data and sine data is less than 0. So this means that we're going to erase this first so that we can have a clear sheet not to write on. And this is for the data information. So here, um, the information is tangent of data is equal to positive 7 over 24. So this means that tangent is positive. So the terminal point of data must be in quadrants 1 or quadrant 3. And then the information sine data is less than 0 means that sine is negative. So in this case, the terminal point of data is in quadrants 3 or quadrant number 4. So the common quadrant for the terminal point of data will be in quadrant number 3. So which means that the x and y coordinates of the terminal point would be both negative. So from the information here, tangent data is equal to y over x. And that's going to be 7 over 24. But since we are in the third quadrant, it should be that y is equal to negative 7 and x is equal to negative 24. So let's write it down here. Y is negative 7 and x is negative 24. So using again the relationship of x and y with the radius r of a circle, then we have x squared or negative 24 squared. So that's going to be the 16, 96, and then we have here 8 and 4. So this is 576 plus the square of 7 is 49, and that's equal to r squared. So 576 plus 49 is 625. So r squared is 625. So this means that r is equal to the square root of 625, which is equal to positive 25. So note that we did not write the positive negative sign anymore because r is always positive. So in here, we need to get the value of sine beta. Sine beta is y over r, which is equal to negative 7 over 25. And then cosine of beta is equal to x over r, which is negative 24 over 25. So in order to evaluate now the sum and difference of the sine, cosine, and tangent functions, let's go back in the previous slide. So sine of alpha, so sine of alpha plus beta is equivalent to this expression. Sine of alpha is equal to 2 square root of 2 over 3. So let's write it down here. This is 2 square root of 2 over 3. And then this thing here is 2 square root of 2 over 3. And then cosine of alpha is 1/3. Cosine of alpha is 1/3. So going back here, we have 1/3 here. And then this thing is also 1/3. And then cosine of beta and sine of beta. So cosine of beta is negative 24 over 25 and sine of beta is negative 7 over 25. So we have here negative 24 over 25 plus this thing times negative 7 over 25. And then this one will be cosine of beta is negative 24 over 25 plus this thing times sine of beta, which is negative 7 over 25. So simplifying this further, we get this will be 2 square root of 2 times negative 24. That's going to be negative 48 square root of 2 over 3 times 25 is 75. And then 1/3 times negative 7 over 25 will be negative 7 over 75. So we can write this as negative of the quantity of 48 square root of 2 plus 7 all over 75. So that's the value no, of sine of alpha plus beta. Now for cosine of alpha minus beta, so multiplying these two, no, we get 1/3 times negative 24 over 25 is negative 24 over 75. And then plus the product of these two, which is negative 14 square root of 2 over 75. And so we can write this as the negative of the quantity of 24 plus 14 square root of 2 over 75. And then for tangent of alpha minus beta, so again, let's look at the value of tangent of alpha. Tangent of alpha is equal to 2 square root of 2. So this thing is 2 square root of 2 minus the value of tangent of beta is 7 over 24. And then for the denominator, we have 1 plus 2 square root of 2 times 7 over 24. So simplifying this further, we get 24 as the LCD. And then we have here 48 square root of 2 minus 7. And then in the denominator, this is 1 plus 2 square root of 2 times 7. So that's 1 plus 14 square root of 2 over 24, which can be combined as 24 plus 14 square root of 2 over 24. So simplifying this complex fraction, we will be getting 48 square root of 2 minus 7 over 24 plus 14 square root of 2. But take note that you need to rationalize the final answer. Now, for the case we're in, we're looking for the value of the other three trigonometric function like the cotangent, secant, and cosecant. We can make use of the reciprocal identity. So if we need to find out the value of cosecant of alpha plus beta, then it's equal to 1 over sine of alpha plus beta. So in this case, you just need to get the reciprocal of sine of alpha plus beta. And then since there is a radical in the denominator, you just need to rationalize the denominator. So this ends our video about the sum and difference identities. So I hope that you learned something from this video, and please do not forget to subscribe to my channel. Thank you for listening.